Hi, everyone. I'm Lynn Trong with the National Renewable Energy Laboratory, and I'd like to welcome you to today's webinar hosted by the U.S. Department of Energy Solar Decathlon. Before we begin, I'll quickly go over some of the webinar features. For audio, you have a couple options. You can either listen through your computer or telephone. If you choose to listen through your computer, please select the mic and speakers option in the audio pane. By doing so, we'll eliminate the possibility of feedback and echo. If you select the telephone option, you should already see a box on the right that will display the telephone number and audio pin. Panelists, we ask that you please mute your audio device while you're not presenting. If you have any technical difficulties with the webinar, you can contact the GoToWebinar's help desk. If you're having difficulty viewing the materials through the webinar portal, today's webinar is being recorded and the recording will be available. And now for today's presentation. Our webinar today is Solar Decathlon, What is Good Design? Our speakers today are Rachel Romero, Project Leader and Energy Engineer at the National Renewable Energy Laboratory and Design Challenge Manager, Sam Raskin, Chief Architect at the Building Technologies Office and Co-Director of the Solar Decathlon, and Holly Carr, Co-Director of the Solar Decathlon. I'd like to welcome Rachel to start today's presentation.
Hi teams, this is Rachel Romero. As Lynn said, I am the Design Challenge Manager, and today we're going to welcome you to the new Solar Decathlon. We are going to talk about succeeding in the Solar Decathlon, and Sam is going to give us a great presentation on what is good design. So at this time, I'd like to introduce Holly Carr. Holly Jamison Carr is the Acting Director of the Department of Energy Solar Decathlon. Ms. Carr has also served as the manager of DOE's Better Buildings Alliance, a voluntary energy efficiency partnership involving over 200 public and private sector partners and over 11 billion square feet of U.S. building space across commercial offices, healthcare, higher education, hospitality, retail, food service, and grocery sectors. Previous to her work at DOE, Ms. Carr managed dozens of public, private, and federal sustainability projects, assisting clients to implement environmentally preferable strategies for building design, construction, and occupancy. Holly?
Hi there. Thanks very much. It's great to be with all of you today. And I can say that as a team, our Solar Decathlon team is just super excited about the changes that we've put together for the Solar Decathlon moving forward, and I'm here to tell you about those changes and why we're so excited. Now, just like in the past, the Solar Decathlon is a collegiate competition with 10 contests surrounding energy efficient and innovative building design. But this year, we're really excited to merge the Race to Zero and the Solar Decathlon into a single competition, which we think has something for absolutely everyone. By bringing these two competitions together, we are able to increase the collaboration opportunities between students, provide additional building opportunities for schools, all the while reducing the financial commitment required for participating teams, and will also dramatically increase the public outreach and engagement of this event, as you will see momentarily. Let's go ahead and run to the next slide, please. So this is a nice visual that kind of lays out the changes to the Solar Decathlon this year. We now have two challenges, the Design Challenge and the Build Challenge. The Design Challenge is the competition formerly known as the Race to Zero, and the Build Challenge is the original Solar Decathlon as you might be familiar with it. The Design Challenge now comprises 6 divisions. We have 3 housing or residential divisions. Last year, we added elementary school over there on the far left, which was tremendously popular. And this year, we've added office buildings and mixed-use multifamily as 2 additional divisions where students design a building that's powered by renewable energy. Now, with the Build Challenge, we also now have 2 divisions. So the Build Challenge is, as I'm sure you're aware, this is the challenge where our teams not only design, but actually build a residential building. Now, the two divisions we have this year are the National Showcase, which is, again, what you're familiar with as the original Solar Decathlon. In the National Showcase, our participating teams really have the opportunity to showcase their university and their work at the national level. So those students, those competing teams will be bringing their completed home to the Solar Village, which this year, or in 2020, this competition round, will be held on the National Mall as a part of the Smithsonian Folklife Festival. So we are just beyond excited to be partnering with Smithsonian Folklife Festival and to be able to give you and our student teams so much visibility at a national level. Really excited about that. For the local build, this is new for this, this round of the Solar Decathlon. In the local build option, students build their homes in their local region and compete in that local region. So they will not bring their homes to the National Showcase, but they are invited to bring some sort of display to be on the National Mall as part of the Solar, as part of the Solar Village. We also have prizes for both the local build and the National Showcase. These are monetary prizes, and we're feeling very, very good about those. And we hope to announce the prize amounts in the next week or so. So be looking for that announcement from the Solar Decathlon team. We have, I'm going to go ahead and move us to the next slide just to provide a little bit more detail on the contests. So this year, the 10 contests are aligned across both challenges. And just like in an athletic decathlon, teams must perform well across 10 contests to be the winner. Teams are evaluated to determine how effectively they integrate energy efficiency into these well-designed, high-performance buildings that really push the envelope for consumers and industry. In the design challenge, a single jury for each division or each building type will review all the competing teams. In the build challenge, 7 of these contests will be evaluated by juries, and 3 will be scored based on home performance and functionality. What's interesting about this model is that teams can choose what is most important to them and really strategize to choose their targets and design their homes accordingly. So with that, I will turn it back over to Rachel and Rachel, who is the Design Challenge competition manager. Rachel?
Thank you, Holly. All right. So now we're going to go into what is good design. And Sam Rashkin, our competition co-director, has years of experience with understanding great housing design. While this may strongly apply to residential, many of the same concepts apply to commercial buildings, as well as anyone competing within both of the challenges. Great whole building design helps us meet our goals of innovation, cost effectiveness, high quality, resilience, great interaction, efficiency, and being locally responsive. So this webinar will serve as one of your resources. Your faculty at your collegiate institution also serve as an excellent resource. In addition, all team members can find additional training on the Building Science Training website. To help meet the objectives of the program, participating students in the Solar Decathlon are provided with a comprehensive building science seminar series designed to enhance their academic curriculum. This seminar is available online to the collegiate team members at no cost to you, including on-demand 1-hour modules. In addition, other topical webinars like the one today are provided to support skill development and technical progress. Through the seminar and the webinar series, students have the opportunity to learn more about strategies for high performance, energy efficiency, and energy production than would have otherwise happened in the classroom. So all team members must complete a free building science training offered. The trainings are available on demand and cover the principles of high performance buildings as taught by renowned industry leaders. As soon as the organizers have an updated team roster, students may access the training starting at the end of October. Upon completion of each video, students will be prompted to answer a few comprehensive questions. And then upon completion of the entire set of videos, a certificate will be provided to show completion. Or all of that, the building science requirement may be waived by the team's faculty lead with confirmation of equivalency for courses that each student has successfully completed as indicated on their team roster. So with that, I will turn it over to Sam Rashkin, DOE's Chief Architect, to share with us about good design. Sam?
Hey, thank you, Rachel. I'm going to load up my slide deck here. Good. So welcome, everyone. We're going to talk about what is good housing design. Now, if any of you went to a professional lawyer, doctor, any accountant, any professional, you want them to be inspired for sure. But you would also want to know that any and all of them have a process to assure a professional outcome that makes you bring them into play in the first case. So what this is about is a process for you to add to your creative inspiration to ensure good housing design. Now, I'm going to talk about why good housing design and all of that, but first I want to cover some basics about zero, which is why we're here in the first place. And I just want to go over why zero, what zero is the future, what, why, and how. Now, first, some signs that zero is the future. One is just the growth that we're seeing here at the Department of Energy. Our Zero Energy Ready Home program has doubled in number of certifications over the last 3 years. We've grown to nearly 3,000 homes, and we're well on our way to exponential growth. A very good sign that zero is the future. In addition, there's so much infrastructure in place with the Zero Energy Ready Home program. In addition to the thousands of certified homes, we have over 10,000 homes in the pipeline. We have 400 builder partners who have been fully vetted in terms of the technical specifications and all of the program construct. Also, we have fully vetted, we mentioned the fully vetted national program requirements. We also have marketing and sales resources and a full suite of technical resources. So we're fully equipped to deliver zero to the professional marketplace. Other signs, of course, is the number of states that are starting to build to our specifications, and this map shows a expansive coverage across the country of participation in the Zero Energy Ready Home program. But it's not just us. There are surveys and censuses being taken. Here's one by the Net Zero Energy Coalition showing that in terms of the number of cumulative zero energy homes in the marketplace, it's nearly doubled from 2015 to 2017, growing from over 6,000 homes to over 12,000 homes that have been surveyed by census out on the landscape. And it's not just this organization. Parks and Associates is another group, and they've done their survey. They found a 75% increase in zero net energy home construction from 2016 to 2017. Another sign that zero is the future. And maybe most significantly is just the builder responses themselves to a query about whether they've built or plan to build a net zero home. An independent study by Dodge Data Analytics shows we've gone from 21% positive in 2015 to 44% of the builders indicating in 2019 they plan to build a net zero or zero energy ready home. Again, doubling the amount of interest in this type of construction. Zero is the future. And of course, we can look at the local level at all the activity involved. And across the globe, there are 19 mayors, including about a dozen in the US, that have signed a net zero carbon pledge, whereby they have policy to ensure all new buildings are net zero by 2030 and all buildings by 2050. And even going beyond local to state level, we're seeing growing number of states moving to zero energy codes. This includes California, interest in Oregon, Massachusetts, Rhode Island, Florida, other states, so much so that the New Building Institute is setting up a zero energy performance index for state energy codes as they track their way to zero. Zero is certainly the future. And since it is the future, it's important to recognize that it's part of where the codes are going, and it's also so much acceleration in how it's going there. From 2006 IECC to 2012, just in that 6-year window, the rigor of the energy codes has increased by nearly 40%. And as we move to zero codes, we should recognize that we're also entering the risk zone. These super high performance buildings bring along with them additional challenges that have to be met as architects and engineers. Let's cover 3 key risks. One is water protection. If we look at going from a less efficient to more efficient enclosure, the amount of thermal and airflow is dramatically reduced. And that means we have a water protection risk. And that's because the inside surface facing the cavity on the cold side is going to result in a colder surface. And the reason is with less thermal flow going through the assembly, that sheathing face or drywall face towards the inside cavity is going to be much colder, less heat getting to it. And as a result, we have less drying potential and more wetting potential that has to be managed. The surface is colder, more potential for condensation, more insulation means less drying. We need comprehensive and truly effective water protection to avoid moisture problems. The second risk is comfort. Again, much reduced thermal and airflow in a more efficient enclosure. And so as a result, we have much smaller airflow. And because cooling seasons start later in the year and heating seasons also start later in the season, we have longer swing seasons when we don't have our systems providing cooling, which means we don't get accidental dehumidification, which means we need proactive strategies for managing moisture. It also means we have to be assured of getting full mixing because we have so much reduced airflow. And historically, we've not been rigorous in how we address sizing of ductwork and airflow and ductwork. That has to be managed. So we have to ensure comfort. And the last risk is indoor air quality. With the reduced airflow, we have much less dilution, so we need a comprehensive approach to indoor air quality. So what is zero? In many ways, zero is risk management. We're starting with an advanced enclosure that would be a code enclosure that's already entailing these risks we talked about, and now we're going to optimize it, maybe go 20, 30, 40% above code with even more insulation, more air tightness, and better windows. And we want to do that, by the way, to mitigate the risk of being obsolete in the future. Now more than half the energy use is going to be the components inside our home, appliances, lighting, equipment, fans. Those should be all Energy Star or better. Together, the enclosure and components assure us of a comprehensive strategy for energy efficient performance. Now let's manage the risks. One, if we are more vulnerable to moisture issues, we need comprehensive water protection. If comfort is additional challenges, we need to ensure comfort solutions, including moving the ductwork in an optimum or indoor environment location, and comprehensive indoor air quality strategy, source control, dilution, and filtration. And this is our balance of energy efficiency with performance. And finally, if the home is this well equipped with energy efficient solutions, that means a system to go to zero. Let's make sure we have no cost, low cost details that make our house zero ready. And so with all this, we have a house to the power of zero. And in the case of the competition, you're building to the zero energy ready home label requirements. And this label is a quick assurance. All these 6 systems are being met. So this is what we're doing with zero. And in addition to the future, we're going to be adding resilience and even more water conservation, recognizing their growing challenges as well for new housing. And the home of the future actually even looks more like this, where we actually get into integration with electric vehicles. We even get more advanced thermal protection. We are fully integrated with the grid. We have smart home technology, onboard diagnostics with comfort systems. We have natural comfort design, battery storage. The whole future where we're going is all set up to deliver a tremendous improved product for American homeowners. So why are we going here? Why zero? One, it's a better experience, better health, better comfort, better moisture protection, better quality, and a house that's actually future ready to meet and exceed where homes are going. And Secondly, it's lower ownership cost. Every month you spend less, where the savings each month on your utility bill are greater than the increase in the mortgage to pay for the improvements, plus maintenance savings and health bill savings, because these homes are built so much more healthy. Also, from a builder perspective, they're going to dramatically increase their customer satisfaction because of the experience and cost savings, and they're going to reduce their liability because of reduced rework and higher quality control with independent verification. And from a differentiation perspective, they're going to position themselves as leaders in the industry, and their home buyers will become their new sales force. So also why? Because of the builder experience. And from a societal perspective, there are hundreds of billions of dollars of utility bill savings to be had, millions of job years of work, over millions of metric tons of carbon, which results in cleaner air and cleaner water, and billions of dollars that can be returned to local government because the housing stock has higher value and results in greater revenue to the local communities. So the big challenge is, how do we get to this future? And I'll just only going to say this, is that we have a lot of disruption ahead. We have 3 new realities that are truly impacting the builders already, and 5 housing crises and 3 housing disruptions. All that is subject for another time. Maybe at the Solar Decathlon we'll have time to discuss some of these things, but clearly that's all part of how we get to zero. We have to be integrating with where the industry is going in the future. The big thing though, zero is a superior customer experience. Again, we talked about the savings, year-round coziness, total comfort, healthy living, complete moisture protection, quality assurance, and this future value. And that is great. But in fact, it's not enough. We have to deliver the total experience as builders to the home buyer. And there are 5 key experiences that I write about that are the community experience, design experience, performance experience, quality, and sales experience. All 5 are critical. And I'm a tough scorer, and I would often score most builders to look something like this, where 0 means you hardly address the experience, and 5, you're outstanding. And the challenge will be, if we do 0 perfect and do a great job, we'll just bump out the performance side of the experience. And it's not good enough. At the end, we have to get here. So we have to figure out how to integrate 0 with all aspects of the home. And you're here today. We're going to talk about how do we make the design experience great in zero energy homes. So that's our discussion. This is based on workshops I do, based on my book, Retooling the U.S. Housing Industry. That's the source. The concepts here come from 25 years of practicing as an architect, researching, studying the industry. Then I've been doing workshops going on now the 5th year with hundreds of builder executives, vetting, getting feedback, iterating, a lot of concepts you're going to hear today. And so that's what I will be presenting. But you don't have to use my platform, my set of criteria for what is good design. The important thing I mentioned is you do need a process so you consistently deliver great housing design. And if you don't like the concepts that I present, do not worry. You don't have to do everything the way I'm going to be saying. It's based on the experience I just laid out. Your professors will have lots of their own great input to give you about what's good design. I just want to show you one framework, and I hope it's helpful to you. So it begins with, like all my modules I talk about of the 5, with how do we optimize the experience, in this case, housing design. We'll talk about the what, the how, and the why. So the first thing we want to do is optimize our location. So we do that by fitting our design to the site. Second, we want to optimize nature. Nature is a free gift, and we do that with natural comfort. Some of you who are students may know this concept more as passive solar. Words matter. The word passive is a horrible word. Natural comfort's what I choose to use instead. The third thing you want to do is optimize space. You do that by right sizing the right way. And then the fourth thing you want to do is optimize the form. You do that with architectural integrity. And lastly, optimize function. And you want to integrate all the systems in a home so they all work together with the design. And the reason we do this, the why, is because how you live matters. How you live outside, how you live inside, and details make all the difference. And the way we're going to get there is we're going to talk about 5 concepts for how you fit to site, 5 concepts for how you deliver natural comfort, 2 strategies with 10 concepts for how you right-size the right way, 3 concepts for architectural integrity, and 12 systems in 3 groups for how you integrate systems and how they must be integrated for a good design. So let's start with fit to site. And the 5 concepts I lay out are you want to optimize the view, you want effective drainage, regionally appropriate materials, regionally appropriate resilience, and you want community connection. Those are the 5 key pieces. Now let's take one example we all study in architectural school. This picture is taken from my visit a few years ago, and I don't have to tell you what the name of this building is. It's Falling Water by Frank Lloyd Wright, probably one of the most visited homes in the world. It's touted for its amazing architecture, but I'll suggest to you, is this a good design for a site that gets more snowfall per year than almost any other place in the country? Long, flat, overhanging slabs, surfaces that are flat roofs over occupied space, massive amount of freeze and thaw going on. The outcome is that a building like this is so expensive to maintain, maybe it's achieved the only function it can. It's a museum where you get hundreds of thousands of visitors so that the revenue is there to maintain it. A building like you design for a climate like this should not be a snow capture solution, again, so vulnerable to freeze and thaw. Just one view of an iconic building that we always talk about as a great example. Another building we study as a great example is Philip Johnson's Glass House. Again, how can you be comfortable in this building? An R2 virtual 4-sided assembly, and once you don't have comfortable surface temperatures around you, you can't be comfortable. And you can only imagine how cold the surface temperatures are or how hot they are during the summer. And if you put even curtains on this kind of structure, now you'd wind up where you'd be warming the windows enough that the airflow around the curtains would create lots of opportunity for condensation on the windows as well. So is this a good solution fit to site, or just a structural or a piece of sculptural statement really as a piece of architecture? So I can go on and on. So even looking at iconic buildings, I will be critical whether or not they're good solutions for fit to site. Here's a house in a neighborhood I live in, and a basic standard floor plan from the architect's models was selected and dropped on the site. And what you should know is the main orientation, north-south, with about 90% of the windows are in the front and the back of the home, yet the main view is off to the side of the home. And so here you have this incredible gift, a view of a beautiful pond, and the house completely ignores it. As a result, the subsequent homeowners, after the builder sold it, have added windows to the other side and a deck off the side rooms. Even though it's not optimized for the floor plan, the homeowners did the obvious thing. You always take advantage of a view. You never ignore it. What do you do if you don't have a view? You create one. We always go, okay, what do? We have no view, create a view, and that's where courtyards are your friend. They can be landscaped with materials and with plants and shrubs and water treatments, and all of a sudden, even a site without a view has one. And then, of course, you can add the floor plan layout so it optimizes the views to the courtyard. So if you have a view, take it. If you don't have a view, create one. Effective drainage, another house in my own neighborhood, I'll use examples, and this is not what you want to do to have the water slope right up against the house. It's so easy during grading just to create a swale and create drainage solutions that will avoid tremendous problems into the future. And once you have these kind of problems, it overwhelms every other experience the homeowner has in that home. Ask anyone who has a wet basement, nothing else has the impact because it's a worry and a fear that never goes away. It's a cost that's substantial. You can never avoid, or you can never ignore drainage. You have to optimize how the water flows away from a house and gets to good removal from the site. And here's even drainage considerations on the roof when they're ignored. A valley roof in a location that has big trees or likely to have big trees means you're creating a collection device for debris. Valleys just cannot lose their debris nearly as effectively as shed roofs. So you have to think about your design, particularly if you're in a location with lots of trees, mature trees, or plan to have mature trees. And then regionally appropriate materials. Wood siding in a place that gets to like 110 degrees in the summer is probably a difficult choice because of all the maintenance and painting, the difficulty maintaining the wood in a very hot climate. So again, we have to think about our materials, and that's why the predominant material in this region is a stucco design. Stucco is so well suited to this kind of climate. It's much lower maintenance. It creates a lot of deep recesses to shade windows and so forth. Very significant difference between an appropriate material and inappropriate material. Similarly, ceramic tile roofs do not work in cold climates. Again, the freeze-thaw cycle results in lots of cracking and wear and tear on tiles. They are perfectly suited for more mild climates, but very cold climates, not your friend to put a ceramic tile on the roof. Inappropriate material for the location. Also inappropriate materials would be materials by color. This is Melbourne, Australia, where long summer season, many days way above 100, and you don't want a surface material that's going to be optimizing the heat collection when you're trying to avoid getting overheated. So compare Melbourne, for instance, with Bermuda, where they go with all white roofs that are reflective, and right away you're getting free 20 to 30 degrees of cooling in the spaces below because of the reflective material. Regionally appropriate materials make a huge difference. And regionally inappropriate resilience would be what I observed when I moved to California in the 1980s. Virtually every home in most subdivisions were using wood shingles, which is basically kindling for the roofing material. And the Oakland Hills firestorm in 1991 came along, and you could observe the one house standing over here was a house with stucco cladding and cement tile roof. The right materials for the right location are obvious after a disaster event like this. And regionally inappropriate resilience, if we're going to build in locations that are flood prone, we have to build appropriate designs for those locations. Having homes that can be flooded, it's not a matter of if, but when in these locations. In contrast, Kiowa Island, they know they're prone to flooding, and the requirements in this subdivision was every home had to be raised like 9 or 10 feet above grade level, just so they're protected. And the last concept in fit to site is good community connection. So if all we have when we design home is a garage and a door, it's very little likelihood we'll encounter our neighbors or make good connections. So here's a typical row house where the garage dominates the front. In contrast, if the garage is in the back, we have the opportunity for neighbors to meet each other at a much more significant level. Or even better, if we even have front porches integrated, front porches are great ways for neighbors to make connections. Now, if we want to even go further, we can have all our neighbors gather around a common courtyard. And this townhouse actually has this courtyard. And again, the interactions, the community connection goes up like 10x from the ones we showed you previously. There are amazing differences we can make in the same amount of land area based on our design choices for community connection. And front porches are always a great deal, a great solution for doing that. So front porches are substantial. Always consider them almost in any neighborhood that you design for community connection. Okay, that brings us to natural comfort. And, you know, we can go back over 1,000 years and see how good we could be addressing natural comfort. These are the cliff dwellings of Mesa Verde, Colorado. The Indian tribes found a perfect location where the cliffs facing south, the opening facing south, created an overhang that would block the summer sun, let in full winter sun, built with thermal mass materials that would store the heat during the day and at night continue to keep people comfortable even when the sun was no longer there. It was amazing how effective these solutions were over 1,000 years ago. Similarly, the Taos Pueblo community in New Mexico didn't have the caves, but basically used thermal mass, recessed windows, thick walls for storage to buffer the spaces from day to night. It was amazing how effective these design solutions were. And then we look at what we do today, and we're just brute force. We will just say, come on, nature, we'll give you everything we got, and we'll blow as many megatons of cooling as we can into these buildings. You will die in these buildings if there's a power failure and you cannot get out. These buildings are so unresponsive to the natural forces around them that they will superheat and suffocate anyone in them the second that the power stops. This is natural comfort ignored. To build a glass community in a desert doesn't make any. So look at the experience improvement we get with natural comfort. We get glare-free views. We have 25% or more free heating and cooling. We have superior comfort because we have surface temperatures radiating heat in the winter and radiating cool, so we're absorbing our heat in the summer. We have all this natural light, which everyone prefers, and we introduce fresh air, which everyone loves as well. That's a total amplified, superior experience when we integrate natural comfort. And here's examples of glare-free view. Instead of having window coverings blocking the views with shading and appropriate orientation, we have views with thermal mass materials and the sun heating them up during the day. We feel warm, all the savings on cooling and heating. Lasso Blue is the inland climate, to 45% savings on cooling, depending if you're coastal, and about 17 to 20. First is get the orientation right. Orientation, you have a site with amazing views facing west, not an optimum orientation, you a great view. There are other solutions that can come into play. Once you have solar orientation, shading is so effective it blocks the high summer sun to savings in the heating. And then thermal mass storage is our natural comfort control. It will absorb the heat. Prevailing breeze orientation helps us capture a cool breeze location. Again, these details cost virtually nothing. They're just good design. And here's how they apply. Orientation, shading, and thermal mass are how we get to natural heating. All these tools help us get to natural cooling. Cross ventilation and prevailing breeze orientation help us get natural fresh air. Natural comfort control is thermal mass, and natural lighting is orientation and shading. We can apply these tools and get to natural comfort. And solar orientations, the first step I mentioned, the most important. In the summer, the sun is rising in the northeast and setting in the northwest, so we have a very larger arc to deal with. In the winter, we have a smaller arc as it comes up in the southeast and sets in the southwest. And ignore solar orientation, you see images like this, and what I'll call your attention to is notice all the windows, as there's so much heat coming in that's unwanted that the owners, instead of trying to open and close the windows throughout the day, leave them shut all the time, which begs the question, why is the window there in the first place? You're now getting rid of the view, you're getting rid of orientation. And you go up and down this entire block, every house looks the same way, except for one window above the door, which is inaccessible, so they don't have the solar covering, but more importantly, it's so deep back and shaded that it probably doesn't need the window covering to block the sun. And now, this is owned home, and I sold these pictures from him recently. The active solar orientation, solar shading is. This is Paul's home in, I believe, Rhode Island. Oh no, Connecticut. I'm sorry. And this is a picture, obviously, in the winter. And in the winter, what you can see virtually all, they live only upstairs, and you can see the sun completely hits the south-facing windows in the summer. In the winter, go to summer. Overheating the space, the heat stored in the concrete and released at night. It looks very attractive, that spaces with thermal storage aesthetically as well. So this is a home with thermal storage with concrete tiles on a slab floor, or another home with concrete on a slab floor. And again, all the south windows. Amazing how this space must feel even on the coldest days. And here's how flooring materials, some additional potential savings by avoiding the need to provide a floor covering. But again, the concrete provides a thermal control of the building. Prevailing breeze orientation and cross ventilation is basically positioning our openings based on prevailing cross ventilation flow through spaces, very basic concepts that will enhance our designs. And spaces must feel so connected to nature, the comfort will be superior to a home where you just brute force throwing in air conditioning from compressor equipment. Here's a design I did back in 1984 to show you how natural comfort designs can be applied. All the design tools are applied in one simple design. I'm going to come back to this as an example of right size and the right way later, but notice in this small lesson, we have south orientation, also orientation to the prevailing breeze. This is in Sacramento, California, where the delta breezes come in from the south every day. Clock. 20% increase. So there are 10 concepts for how we right size the right way in 2 buckets. The first is we want to leverage space. We want to get the most out of the square footage we have. We want open layouts. We want to eliminate or combine rooms. So if we don't need spaces or they can be combined, let's do that. A big solution for me who knew built-in furniture was a strategy for energy efficient performance, but basically built-in furniture makes a space live about 30% or more bigger, because you get rid of wasted space and you get so much storage per square foot. And then you want to minimize circulation. I don't know any client of mine that we want to be generous. And it could be either wider at the indoor outdoor linkages, so there's an appearance of size, or bigger as the indoor spaces. You want to enhance the spaces we have, make them live bigger. We do that by the use of colors, natural lighting, which will be the byproduct of the natural comfort. Artificial lighting strategically to make spaces feel vinyl. These concepts overlap. Books called The Not So Big House and derivations from that. So a lot this you'll see from outdoors, it lives bigger. No built-in furniture equals clutter. I can put another equals here, equals stress. If you're a builder, this is a horrible ambassador for you and the work you do. You want to make it so your homes are strategically set up so your owners can have the least clutter possible. Built-ins are your friend for that reason, and also they'll let you build smaller homes that live bigger. So here's an example of built-in furniture. The window seat gives you functionality, more use of the space, the storage below the window seat, full height shelves on either side with storage below with the drawers. There's an amazing amount of storage capabilities and clutter reducing benefits with this simple addition. Again, the hutch and the shelving, the window seat, these rooms will live so much bigger. There'll be no clutter, there'll be less stress level. And we have little spaces below a stair. We can convert it to all space. We almost create an office out of a wasted space. It's normally just some storage for suitcases. And our trim and finish need to be done system packaging. The auto industries for cabinetry, and then we can have a best quality that has a best cabinets, trim, and hardware. But we should have packages that are integrated and match, have different solutions for different budgets, but we need to get this organized. And so all these things need to be matched up. Trim, hardware packages, all those things have to match up. And then look at the trim of formed. It's a completely different living experience. And So much so that there are whole studies done looking at colors and which are most effective. And not only are they effective in terms of design expertise, they're effective in terms of property values. There are studies that are finding out that the right colors are creating monetary increases in the value for our homes. And look at the difference just with lighting and color when we go from a parking garage with no attention to lighting and color and a parking garage with some attention to lighting and color. It's significant compared to switch in this parking garage saves $170,000 annually almost on the utility bill to put all the additional cost. This is from design. And so we're going to have to figure out how to use all these new lighting choices, conventional LEDs, OLEDs. The capabilities of this new technology are amazing, and the experiences they'll deliver are equally transformative. And again, the moods, the color, the degree of variation of warmness in the lighting, all those things are at our fingertips now. And designers and leverage this technology. I mentioned when I come back to that design I showed you earlier for natural comfort. Bedrooms have tremendous functionality. Even the hall users, because there's a door between the bathing department and the sink, full laundry room, full eating kitchen, and extensive cabinetry and family room, and yet it's less than 1,500 squares. Compact circular foot live like about 2,400 square feet, I would claim. And then the varying ceiling heights I would achieve even back in the 1984 when I designed this with a SIP roof and letting the vault of the SIP be the higher ceiling on the front and the back of the house and go flat in the middle, so that's your space around your heating cooling system in conditioned space environment. And then your indoor outdoor linkages, and we mentioned all the shading and trellises so you have comfort throughout. The home. So right at the beginning, efficient and functional floor plans and expert materials, details, and color. To me, those are the three components to architectural integrity. And when we travel to Europe, and here's Portofino, Spain, this is on the top part of the country on the left side as it extends over to France. And it's an amazing, beautiful streetscape. Yet look at the architecture. It's a flat front, simple roof. You don't need to be complex. Colors, positive and negative spaces, details, they're transformative. We don't have to make architecture and design any more complex than it needs to be. We can achieve such inspiring solutions and spaces, indoors, outdoors, just with simple and functional choices. Compare that to this design I picked from an ad highlighting some beautiful cladding or roofing materials rather, but yet I go, when you have this level of complexity, that is a design failure. This is a personal choice. I don't want to, I want to make sure everyone understands that, but when I see this much complexity going on, we're just not thinking about how we can do this so much more elegantly. Simple and functional is where I believe you want to go. And also notice in this home, which is common throughout the Eastern Seaboard, fake shutters are used extensively. I think that's just a throwaway. It's a silly idea. And it's because natural shutters are not only beautiful, but they're functional. And they can really be a solution for helping us have natural comfort. And when you see natural shutters being used, you go, why aren't they being used more? They look great, they work better. I don't know how much more they cost than fake shutters. I haven't cost them out, but this is so attractive. I'm sure it's worth a small extra cost from the fake shutters. Integrity. And I would always like showing this house. I found from just searching out design sites, I love it because it couldn't be more simple. A simple, basic hip roof, flat walls. You have a front porch, so that's why you have some architectural interests off the front that's functional, creating a porch. And look at the use of color, look at the details, proportion. It doesn't take that much to create an amazingly inspiring architectural solution. We do not have to go complex. And fake architecture is really disturbing to me. Here's a design as if the only way you would ever see this home would be like on an elevation drawing two-dimensionally. Once you go closer to the home, you see once it goes and bends a small 3 or 4 feet from the garage to the house, that they throw in on the side elevation the material that they use on all the side elevation, the cheaper vinyl siding. And you go, that's so arbitrary, it compromises the whole look. It makes it look like a fake front, a faux front. So we're just not delivering architectural integrity. Now, let's look how we can transition from fake fronts to something with a lot more integrity. So here's a fake front solution for that home, just like I showed you. And we can go to one material that without the fake front, so we're not using the rich brick in front, but then we take that, invest the savings in the brick front and put it into a front porch. I would much prefer the front porch to the fake front every day, and you yourselves can make a choice which is a better solution. The other thing is we want also really functional floor plans that work great and are efficient. So here's a great design where, one, it's not even worrying about what the dimensions are. The furniture layouts tell us whether the space lives like we want it to or not. And you can see with all the furniture, this is a really great house that lives beautifully. And you always want to show your furniture on your layouts. Please, any of you students who are competing, never leave the furniture off your floor plans. What you should also notice is the open layout creates a lot of sense of size in smaller space. We're also getting rid of rooms. We don't use a dining room hardly at all. Let's have a great room where we have combining the dining room and the eating area off the kitchen. And indoor-outdoor linkages, even on a very narrow lot, are created by the front porch and the side courtyard. And then on top of that, look how little circulation is in this house. So you're leveraging all that hard cost investment into really great functional spaces. I'll also call your attention to the design solution. The secret sauce, if you will, in this is a side entry. So now I get a full front room and a full front porch rather than being a pass-through to get from the front to the middle of the house. The side entry is an amazing secret sauce solution to this design. And then you have the quiet side so that the neighbors aren't looking on your active side. When you enjoy your courtyard, your neighbors are not looking on your space. So let's look at how this might work on a typical townhouse configuration. Here's what I call a non-functional floor plan. It's a typical townhouse, 6 units with a postage stamp backyard. And what it means is you have a space with hardly any access to views because the windows in the front are looking to a parking lot. The windows in the back are only to usually the bedrooms in the back to get the view of the postage stamp yard. So it's left with probably little interest, little maintenance, and it's kind of a throwaway backyard. Now, look at what your neighbor sees, your yard, so you have no privacy as well, which is another reason why the backyard would hardly be used. So what if we, instead of doing that, get rid of the backyard space, repurpose it so we can do in the same amount of land space an equal number of L-shaped townhouses with a side courtyard. And what happens is we have a private space, we create a view like we showed you earlier. Where there's no view, we create one with a courtyard. Then we have the quiet side, so we have total privacy. And our active side, we have now all the windows in the public areas of the floor plan where people hang out, having a view of the beautiful courtyard. And then we have the center entry so that we get maximum use of the front with a full room and a full front porch, just like we are shown you in the prior design. Research to find anywhere in the country where this is being done. And I found one of all places in Alabama, Pike Road, Alabama. This is a townhouse development, just like the concept I just showed you with the L-shaped townhouses, the courtyards, and here's the home with the front porches, community connection, such a better solution with no more square foot requirements to achieve the same number of townhomes on a certain size development. And again, the courtyards create all these view spaces from all the rooms, not just the 2 back bedrooms. The whole house gets to look at these courtyard spaces. And then good landscape architects, good materials, good color, and we now created a view where there normally would never be one in a townhouse solution. Again, more townhouses with courtyards, and so you see how this works. And also I want to point out the transformation that materials, details, and color make. So here's a typical name brand food market, and what you see a million times over and over again. And the design choice was a cheap drop ceiling, drop acoustic tile was cheap, cheap lighting, cheap shelving, cheap flooring, and this is our shopping experience in this food store, so far below what it could be. Compare it to, in this case, a Whole Foods store, and they got rid of the ceiling, so they saved money. They got rid of the drop ceiling, and they used color to paint the ceiling. Got rid of the cheap flooring, and they polished the concrete and made a much richer experience. And they invest all the savings in lighting, color, display, and the shopping experience is transformational. This is transformational just because of materials, details, and color. And same thing in homes. If we are attentive to the materials, details, and color, we can create better transformational outcomes. Very simple house, a very affordable house, but time was invested by the designer in proportions, in color, in trim, in details, and a very affordable home with very simple design can become beautiful. Lastly, integrated systems. There are 12 systems and 3 groups that need to be integrated. First, the infrastructure of the home, the structure, the heating, cooling, the plumbing, and the electric. All those have to be integrated into design. Then the livability of a home. There are 4 systems: furniture, storage, lighting, smart home, and control technology all have to be integrated. And lastly, performance. How we manage bulk water that hits the house, water management. How we reduce the amount of water used, water conservation. How we optimize solar, particularly solar electric systems, and how we integrate disaster resistance. Those are 4 performance elements. So structural system. It's insane to do whole number roof slopes. We don't need to do 5 and 12 when 4.87 and 12 will result in exactly a 2-foot or 4-foot dimension with 0 waste, because in this case, if it's 2 foot, we cut the 4-foot sheathing in half and we have no waste. If it's a 4-foot, we don't have to cut any of the 4-foot dimensional sheathing. If we have a simple roof design, we should also make sure we have exact 2 or 4-foot dimensions to eliminate waste and integrate with structure. And there should never have structure that sticks into spaces. We need a total structural system integration. Here again, in structure, we don't want a post that sticks down in the middle of the living space. HVAC should be integrated with the design. It should fit within the structural assembly. It should not bump down and create a unaesthetic pop down or disturb the design aesthetic in the home. Plumbing systems need to be integrated. We shouldn't have a sump pump in a man cave or in a family room downstairs. Ways to think through these layouts. The other plumbing integration is think about all the roof vents sticking through the roof shingles. One builder does this by using air admittance valves and gets rid of all of them. So look at his roof compared to this. And again, by integrating the plumbing choices in our design, we can have a completely transformative look to the roof. The other plumbing system integration needs to be trends. And people are so in love with their dogs and are so desirable of homes that are attentive to their needs as pet owners. It's a very substantial amenity. Like 60% of people own pets, 50% of families have dogs. Be attentive in your designs to what's happening all around you. Putting washing stations in a mudroom is not a big investment, and your pet owners will love your design so much better. So think about your plumbing systems and how they can be augmented to create extra value and experience for your buyers. Electric systems need to be integrated. If I know I'm going to need a lamp in the middle of the room, I can plan ahead for floor outlets. And all the lighting needs to be integrated as well. Raised ceilings, all that needs to be integrated. Furniture systems, I mentioned your design should feature all your furniture. Here's an example that shows that by knowing I'm going to put a dresser in these two locations, I know that the walls for the closet need to start beyond the point where the dressers go so that the doors won't be in front of the dressers. Just simply thinking through the furniture tells me where to put the walls as well. Very important integration. Storage, we have all these systems I've counted in my car, or all these storage capacity solutions for my car. I'm not going to go through these because I definitely want to finish on time, but you can do the same and be amazed how the car industry thought about all the things we want to keep in our car and provide these kinds of capabilities in our cars. This is my list of what should be a storage system in any home. You may add some items to this list, but I put this list together, and any home that doesn't provide solutions for all of these, to me, is missing an opportunity to create a better consumer experience. Storage is so important. It's like not the sexy part when people are going and looking at model homes. It's the sexy part when you're living in the home, and storage is so critical. I'm not going to go through the list, but you need your own checklist and make sure that you're addressing all the opportunities to store all the things that we keep in homes that normally create homeowners to have to either compromise or provide some sort of storage solution that negatively affect the aesthetic solution you designed for the home. So again, mudrooms are a great room to also integrate storage for things that normally are very difficult. Shoes, umbrellas, jackets that normally have nowhere else to go can be accommodated, reduce clutter, better experience. Again, brooms, vacuums, mops, all those things, you should know where they're going to go and plan ahead for them. After people wash, they want to hang clothes. You should have a place to hang clothes next to the washer and dryer. We know what people want. When you know what someone wants, then you're done. Just have to, in your design, integrate what creates a better experience. If you don't do it, someone else will. Lighting systems, all the new technology, you have to figure out how your architecture can leverage it, enhance it, and deliver, again, transformative spaces, because this new technology compared to the old technology. And also outside our homes, lighting is truly transformational. Good lighting design, it doesn't have to light up the whole house. It could be less systems as well. And we mentioned smart home and control systems have to be fully integrated. More and more, this is going to be the expectation of every homeowner. You have to think ahead with your designs, how those will be adapted. And then water conservation, more and more is also growing importance in many locations in our country, maybe more important than the energy savings. So here's a design from way long ago that where I just try to see if I can come up with a integrated wet wall design. And here's in one wall, you have the master bath, hall bath, laundry room, kitchen right off it. So there's virtually an insignificant amount of waste water getting hot water to each fixture. And there are all your wet rooms right off of that. Water management, this is a bad place to have hundreds of square foot of roof just drain right down. Just the water drainage wasn't thought about when this roof design was chosen. And you don't want all this water just running right down like a faucet right next to the entry during a storm. So how you manage how water drains on the ground, on the roof, all those need to be integrated in your designs. Solar system integration. When solar is just put on a roof, on a rack, it looks like it's tacked on. When it's integrated in the roof, it looks better and it has other benefits. It saves you money. You don't need underlayment. You don't need roofing. You basically don't need sheathing. You just put the solar on the framing and it looks better. You'll get daylighting to the first floor. About 15-20% more light will come through than a solid roof. So the first floor will have more daylight and lower maintenance, because when it's time to change the roof, you don't have to pull off the solar system to do your roof maintenance. In every way, it's better, so you want to integrate your solar system in your design. So here's a tack-on solar system on a roof. Here's an integrated roof. I'd ask you which is better. Again, you can see how the daylight can filter through and light the first floor spaces. It's just a better experience, and you see all the savings. I have no sheathing, I have no underlayment, I have no roofing, and yet it looks better. All those cost savings contribute to a reduced cost for the solar system, because now the solar system, in addition to generating energy, is providing a roof to your porch. Here's another example of a solar roof over a cabana type unit off a pool patio unit. Again, you can see the daylight come through, it has total comfort, lots of shading, and it looks beautiful. Disaster resistance needs to be integrated. Here's a solution where we know if it's going to be flooding, we build with concrete block on the lower level, then we can go to wood construction. Joe Stebrick has done a great job laying out a whole strategy for flood and hurricane resistant buildings. It has to be integrated into your design, and not the least of which is maybe raising your homes in locations that are prone to flooding. Of course, the same goes for fire-resistant construction in areas prone to fire, tornado-resistant construction that can withstand impact in those locations, and so forth. So my summary: we can transform how the occupants will live in the buildings we design if we use good design choices. Color, lighting, indoor, outdoor, natural lighting, landscape and hardscaping have to be at least as important as the architecture, I think often more important once they become mature. Finishing, materials, trim, hardware, transformational. Storage not only saves energy because it allows a smaller space with less amount of space to condition to live bigger, but it reduces clutter, stress, it looks better. So if my 1,500 square foot design lives like 22 or 2,300 square feet, and I'm saving 700 square foot at $80 a square foot of cost, that's another $55,000 of hard cost I can invest in the buildings at no extra cost, plus lower energy use. All the technology integration, you have to leverage views, take advantage of the views you have. If you don't, design views into your solutions, and your exterior spaces are as important as your indoor spaces. So how to pay for this design? Just like I said, the hard cost savings, right size in the right way. If I save $800 square feet, I've just got myself about $60,000 to reinvest in the home. And simple designs are easy to build and cost less for additional savings. So here are my recommendations I give to builders who go to my workshops. Invest in the experts. It's worth it. Design, color, lighting, technology, landscape, and more. They'll make the difference and get your designs transformational. Design for site and region, optimize natural comfort, right size, then invest the savings in quality design. Built-ins, hardware, materials, colors, lighting, exterior spaces. Simple design choices, and integrate your designs with all 12 major systems. Now, what I do for my builders is I give them this benchmarking scoring card. This is the part of it that relates to design experience. I basically took the construct that I shared with you and I put it into a scoring tool so they can rate themselves from 1 to 5, 1 the lowest, 5 they actually are doing a great job. And they can fill it in for each concept, for site, for comfort, for right sizing, integrity, and for systems, and give themselves an overall score and actually come up with actions how they can improve their designs. Again, you do not have to use what I recommend. Mine is based on 25 years of practice, research, almost now moving to my 5th year working with executives, asking them to tell me, what would you change? What would you have me delete, add, and all the tweaking I've been doing for years working with builders, this is what I've come up with. You do not need to use it, but you should have your own process so you can consistently deliver great designs. Often in the world, I say design trumps everything. It's so important. And so I hope this makes sense. Thank you so much. This is where this comes from. But basically, I hope this is helpful as you move forward into the competition. This is how I would be scoring your designs if I was a juror. Thank you very much.
Thank you, Sam. That was great. It was great for your insights, and we appreciate that.
You didn't say anything about being on time.
You are right on time. I'm so proud of you, Sam.
That's what I wanted to hear.
Right.
Thank you, Rachel.
All right. We are going to talk a few competition logistics information and some details, and then we will conclude with questions. So if you have questions, you can add those to the chat window while we finish up this information. So the organizers want all of the teams to be winners in this program, so we try to provide the necessary tools for you to be successful, like today's webinar. Successful teams know the details of the competition, and they know this because they read the competition guide. It has details on your project constraints, what the jurors will consider, and much more. Carefully review your team's challenge section. Successful teams communicate well, knowing who is responsible for what part of the project. They are coordinated with their collegiate institution, and they submit their deliverables on time. The next deadline is November 6th. The organizers require these submissions to help teams stay on track. Successful teams learn from professionals, finding great industry partners who provide guidance and reviews, suggest improvements, and donate goods and services or other things. Successful teams finish their project. Your team should seek to have a good story behind why your design and or build is the way it is, and have considered all multidisciplinary aspects. And they explain what they are doing well to jurors, the public, and other teams. If you created something good and no one knows about it, your team's score will reflect that. And they read the competition guide. Seriously, we want you to read this. So, the competition guide is available on the Solar Decathlon website. You can find it under About, then Apply. The organizers provided minor revisions for clarification in early October, so make sure to download the new version today. Please note that more minor revisions will be coming again in January 2019 based on questions received and to ensure clarity to the competing teams. Our application site is designed to be straightforward and simple if you haven't applied yet. You can access it from the Apply page on the Solar Decathlon website. It should be completed by a single person, either a faculty advisor or team leader for each team that is applying. If you have multiple teams applying from your school, each application should have a different person submitting an application. One of the first things that is asked will be for you to select your challenge. This will then change what you see on the following screen. Once you choose your challenge, you'll complete the forms with your primary contact information. You'll have the option to download a team roster template. You can indicate your intended division, as Holly described earlier, and pay the $100 application fee. The fee is intended to ensure that we receive committed teams and to provide benefits to teams that wouldn't otherwise be possible using DOE funds. You can submit your application at any time right now, but you also can come back and edit it at any time before November 6th. And you will be expected to upload your additional documents at a later time to the Dropbox link. Please note you can complete your application today and then at a later date submit your project introduction for the design challenge or your build challenge proposal for the build challenge. So get your application in today. So the deadline is November 6th. It is at 5 p.m. Eastern time. For the design challenge, teams need to indicate their intended division, pay the $100 fee, and submit your optional project introduction. Teams will receive feedback on their compliance with formatting and compliance with the division definitions, and all team applications will be accepted. All participating teams will be announced in November. Ultimately, the design challenge will accept up to 8 teams per division in the April presentations, 48 in total, but this down selection will occur following the February submission. For the build challenge, interested teams may begin projects anytime, and they must again also apply by November 6th at 5 p.m. Eastern Time. DOE expects to select 6 teams to proceed in each of the 2 divisions, the National Showcase and the Local Build. This will yield 12 teams to compete over the 2-year challenge. So due in November, for each team, you need to have a preliminary roster, select which of the Build Challenge divisions you intend to compete in, and submit your Build Challenge proposal, along with your $100 application fee. Selected teams will be announced in December. Teams selected to proceed are announced in December, and those that are not selected have the option to enter the design challenge with no additional application fee. Accepted teams are eligible for prize funding, as Holly talked about earlier, and additional details are available on the competition website and forthcoming next week. So with that, we hope you'll join us for the Solar Decathlon Design Challenge or Build Challenge. As one past participant said, the competition was truly an unforgettable experience. We learned so much from the speakers, jurors, and other teams. So get your team together, complete your application today, and get started. Good luck, and we look forward to seeing your preliminary documents in November. So with that, we can always be reached for questions at solardecathlon@nrel.gov. Your general questions can go to solar.decathlon@ee.doe.gov, but we will take any webinar questions at this time.
Great, thanks so much. Thanks, Holly. Thanks, Sam, and thanks, Rachel, for providing such great information. As Rachel mentioned before, if you haven't done so already, feel free to ask any questions during the webinar through the questions pane. We will not be unmuting anyone due to the number of people on the line, but you can also reach out to us after the webinar today as well. So the first question is for Sam or Rachel. How does the design factor or impact the evaluation criteria for each of the challenges? Sam, do you want to speak to that?
Yeah, I'll jump in. There are 2 criteria in particular, the architecture and market potential, where your design will have a significant impact on your score. And by design, we wanted, or by intentionally, we wanted design to account for or be a factor in at least 2 of the 10 criteria, because it doesn't help you or us if the architectural solutions aren't perceived as really good design as well. The marketplace is really very, very strict about this. Its design is so important. So even though the goal is to really achieve zero energy buildings, we really want to see you also really be creative and come up with your solutions, notwithstanding I recommend process to make sure you get there. But those are the 2 I would expect it to weigh in the most. It will partially affect some of the other choices like resilience. Your design will be impacted by choices you make there. So it will it'll be part of a lot of the other criteria as well. But architecture and more market potential.
Which one needs to be designated as the team leader. In terms of the ideal team size or the maximum team size, it really depends on your team's and responsibilities. We will say, though, that communication is key as teams get larger. So we've seen some schools participate successfully in the design challenge with an entire design studio, creating multiple designs, and then down selecting to one that presents in April of 2019. We've seen some where some schools have teams specifically for mechanical engineering, some specifically for interior design, some specifically aspects, and the teams can get large. It could be multiple universities. But really, I would say that the ideal size for a team is the size that communicates well amongst each other and that has clear roles and responsibilities. So who's going to do what task by what date? And so it really depends. Minimum size is 3, maximum number that you can communicate effectively within your own school or your team of schools.
Just to throw one more thing to Joe's answer is, on average, I think I'm seeing 10 to 12 people per team. So if, let's say there are 40 teams, there might be 400 people in the competition, but it plus or minus quite a bit. But that seems to be the average. There's no right sizes. What I'll say is as many as can get value from the content, from the experience, from the collaboration, from learning that happens. As it's just whatever number can, I think, is
the organizers have provided a resources document. This document, once you complete your team application, is found on our project site, which is the groups.io project site. And you can access this document, and it's basically a bunch of links that are coordinated with links and resources that are coordinated with the 10 contests. So there's some general resources that you may want to look at, but for each contest, we've outlined some that may guide you as you learn about each of the 10 contests. So energy
that would suggest you look in the Solar Decathlon guide as well. We list some resources in there.
Great, thank you so much.
I'll just encourage anyone who's not already read your application next week.
Thanks.
For me, I'd just like to say that if any of you are familiar with the old Race to Zero, Nothing's changed except to be confused. It's simply everything's going to work almost identical, except that you're going to be part of this new combined solar decathlon competition